Thank you, Meredith. And I just want to again thank everyone for showing up. And I put a link to the Atmospheric Collaboration Team on the ARPIC website, just so you all get a chance to see, the overarching goal of the Atmospheric Collaboration Team is advancing process and understanding of the changing composition and dynamics and the resulting changes to surface energy budgets. And so all of the work that you all described fits nicely with within IARPIC's Atmospheric Collaboration Team. And is anybody a first-time member? Maybe Emily, is this your first IARPIC? Oh, and Andy as well. Great. Well, thank you both. We're always trying to grow the team. And just want to mention, if there's a particular topic that you want us to cover, please email Meredith or myself or Heiss. We'd love to hear from you all. We're always planning meetings several months out, and so looking forward to your input. So thanks everyone, and I guess Sarah, you're going to go first. So yeah, go ahead and share your screen. And
yeah, thank you. Meredith is actually going to share her screen for me. So we have technical difficulties on this end. Thank you so much. Yeah, so Sara Morris, sit at PSL for NOAA, and I'll talk to you guys a little bit today about Merged Observatory Data Files, which I'll refer to as MODFs for Utqiaġvik or Barrow. Next slide. Thanks. So the MODF and the YAP sitemap originated from this concept of coordinating data managers, scientists, alike in an effort to create and generate model and observation files. For YAP sitemap, we've identified 2 special observing periods from February to March 2018 and July to September 2018. And so these files that I'll be talking about are expected to promote data usability and to hopefully expedite the research process and to generate these legacy data sets called MODFs. Next slide. So YAP sitemap stands for the Year of Polar Prediction Site Model Intercomparison Project, and we are actually toying with adjusting that to be the Model Intercomparison and Improvement Project, so MIIP, so we'll see what happens there. But this is a coordinated model evaluation project that's based on observations at these select Arctic and Antarctic locations during YAP, so during the Year of Polar Prediction. The YAP sitemap steering group specified these Arctic and Antarctic supersites, many of which were identified through ISOA, the ISOA consortium, which stands for the International Arctic Systems for Observing the Atmosphere. There's land-based sites and ocean-based locations. Some of those ocean-based locations are fixed and some are on ships. And Barrow or Utqiaġvik is one of those Arctic land-based sites. And I invite anyone who is not familiar with YAP sitemap to visit their webpage, linked at the bottom there. And next slide. So these merged data files, or MDFs, are one of the primary outcomes of the YAP sitemap. And this is our effort at getting everyone and everything on the same page for observers and modelers. Big task. We have 2 types of merged data files, so MODFs and MMDFs, so merged observatory data files and merged model data files. And for the purposes of this talk, I'll focus mostly on the observation data files that surround Utqiaġvik. But both the MODFs and the MMDFs will be generated in NetCDF formats that correspond to one another, and they'll have the same nomenclature, same metadata, same structure. And so the goal there is that everyone's on the same page and they can utilize each other's data pretty seamlessly. The MODF and MMDF data sets will be archived at Met Norway, and visualization tools have been developed to ingest these files and produce, browse products to kind of look at the data. And this image here, developed by Michael Gallagher, it's kind of a nice overview figure that shows some of the Arctic land sites and how some of the model outputs overlay on that region, so you can kind of visually understand what we're trying to do. But this is by no means every site or every model, but this is just a snapshot of the concept of what we're trying to accomplish here. So next slide. So this meaty figure here was developed by Tennille Utah. And this is an image that describes broadly our process for arriving at an MODF and all of the steps involved. And in the next few slides, I'll kind of step us through these individual sections, but this slide really kind of captures the complexity of arriving at a merged observatory data file and all of the pieces of data and metadata that are needed to come together to produce these final products. Next slide. So these first two sections of Tennille's figure A and B can really be ingested in whatever format that the MODF creator is comfortable using. But for the stations that we're creating MODFs for in PSL, we're able to actually link to these metadata schematics called datagrams that we have already generated for most of our Arctic stations. And Tennille and myself actually published the datagram article recently that outlines how to create a datagram. And in that, we have these machine readable spreadsheets that contain all of the metadata necessary, to troubleshoot, use, process measurements, collect all this stuff collected from instruments. And this image here shows the kind of the general information that's captured by datagrams. And so the things like header information, calibration, processing, instruments and measurement details, and product and archive information. And so that can kind of feed into the metadata types that we're collecting also for the MODFs. And if you could go to the next slide. So this is a Barrow datagram just for one of their platforms, just to give you an example. This is for the Global Monitoring Laboratories albedo rack at Barrow. The front-facing end of a datagram that you see on the left is meant to be a visual sort of metadata, kind of like a poster. So technicians or data managers can quickly kind of sort out the flow between instruments and voltages collected, data acquisition, data products, and troubleshoot quickly what they need to. But this back end, kind of this like, I just threw together a bunch of screenshots of the different schematics on the right. But this backend is a series of kind of metadata schemas and spreadsheets for the data managers specifically that can, be read into programming platforms and ingested actually into our MODF metadata toolkit spreadsheets that I'll talk about a bit later. Next slide, please. So this is another Barrow example. So that first example was more of a long-term platform, and this one is a short-term platform. This was an experiment campaign called DICE, and this is more short-term in nature. This is an experiment that took place at Barrow called the de-icing comparison experiment, or DICE, and it focused on instrument issues of snow, rime, and ice, and how they accumulate on our radiometers, and how those measurement issues might be resolved using different type of aspiration or housing or bolt during data collection. So there's a lot of information, a lot of content on these datagrams. They can be as long or short as you need them to be. But you can see how the front-facing portion of these datagrams is more appealing to kind of a web interface audience, but that backside that's not actually shown on this slide contains all of that pertinent information and the nitty-gritty details, and is more in a machine-readable format. So next slide. So this is the HK table. So this is that next section of Tennille's schematic. And Leslie is on the call, which I'm glad to see because she made this wonderful thing. And so the HK table, which is the Hart-and-Khalsa variable schema table, was developed for the OpSiteMap to provide kind of guidelines for creating MODFs and MMDFs. The table is a JSON machine readable file, also available in a human readable PDF, that relies on standards and conventions used in the earth sciences, so including NetCDF, CF conventions, and the current attribute convention for data discovery, or ACDD. But this table allows or enables observational groups to create modeler-ready MODFs and gives NWP partners guidance in creating comparable model output files. And so you can download this table at Zenodo, and the link is here, and it's pretty wonderful. So I highly recommend everyone take a look at it. Next slide. So this is kind of the big meat of creating an MODF. So this is this toolkit that we've developed, and it could create MMDFs or MODFs, and it should be publicly available hopefully in like August, September. It's developed by Michael Gallagher, who sits in PSL, and he developed the toolkit in Python, but the toolkit is workable together with standard tools and libraries, such as MATLAB, Python, NC Tools, others. And Elena Kish, who also sits in PSL, is coordinated with Michael to produce a MATLAB version for our PSL in-house use, and it's been great and super easy to kind of go between the two. Currently, the toolkit generates 3 feature types of MODF outputs. So we have time series for those stationary single level measurements. We have time series profile, which is that stationary multi-level, so like a tower where you have the same measurement up and or down, either way. And the trajectory profile, so this is measurements like radiosondes, things that move. But an MODF checker has also been developed by Jareth Holt from Stockholm University that double checks that this toolkit, didn't miss something in the metadata that it was ingesting. And Elena and myself have actually created a metadata table for the MODF creator to use when they're describing and notating the metadata for their specified MODF. And so we've called it the AM table for Utqiaġvik Morris. And it'll hopefully be published tomorrow or the end of the week, also at Zenodo. But the goal in creating this AM table was to standardize and ease the process for inputting the variable and attribute information into the toolkit for the creator of the MODF. And so with this toolkit, we're trying to produce these other kind of avenues, I guess, for folks to easily create. So that's the goal here. Next slide. Maybe. Frozen. So, well, the next slide is the kind of the final product. So it's our MODF. And so for the Utqiaġvik site, most of our data is coming from ARM or GML. And so we've had detailed discussions with Utqiaġvik, with ARM regarding how best to coordinate the efforts on these things like attribution or version control of the data within the MODF itself. And for these two specific special observing periods, we've arrived at a place where we feel comfortable with, and everyone's on the same page. But we are noting that the version of the data in the variable metadata, and we're trying to identify ways for ARM to track who downloads the MODF in case there's version updates and if and when the data is modified through this Met Norway portal. But if the MODFs do continue in development past the OP site MIP, we'll continue our discussions with ARM to work out details on where to host files that utilize ARM data and et cetera. And we're also actually discussing options for including several measurements that we have of the same variable when it exists. So for example, at Barrow for this MODF, we're utilizing ARM radiation, but I know that GML also has radiation suites there. So in cases like this, we hope that currently our toolkit allows both to be ingested and have them side by side so that it's all available, which is pretty great. But for the OP site MIP, we're only going to utilize the one set of measurements just because that's what was identified at the beginning for this. So, and then my final slide, which is kind of it's a visual. It's this poster that WMO made that kind of glorifies the OP site MIP. But it's a visually captures kind of this concept of the OP site MIP and how we can get modelers and observers on the same page. And again, the goal of the OP site MIP is to improve our understanding of the representation of environmental prediction systems on polar processes. And this is a large pan-Arctic collaboration along with the Antarctic. And it's really exciting to see these two kind of data sets come together to collate our model and observation outputs. So the OP site MIP final summit is actually August 28th through September 2nd. So it's coming up quickly. And Tennille Utah is working on a publication for the Merged Observatory Data Files for the OP site MIP. And myself and Zen Mariani are working on a publication to follow that up that identifies the special observing period super sites. And so there's lots of action around this, and it's really exciting. So hopefully it goes beyond OP site MIP. So. But that's my presentation. So I think the slides will be online. So hopefully you'll see the images later.
Thank you, Sarah. Appreciate your patience. It was unfortunate.
That's okay. No problem. I just had to bring up my slides really quick.
Sure. I want to share my excitement that this is really I already downloaded these two of the publications that you were referencing. So I'm excited about these datagrams. And I love your idea of trying to inform folks who download data that it may have been updated. It's warnings that we put on all our data, before you publish. Double check that there's not a newer version, or even better, contact the generators of the data and see if maybe there's a new version that's coming out imminently. And so it's just good standard practice to think about potentially offering co-authorship to some of the folks that generated the data, or at least have that discussion with them. But
yeah, absolutely. And that's what, with the attribution, we really wanted to be careful with that and make sure everyone's properly being credited, because we will have so many different institutes and agencies coming together into one file. And so that's a big piece of that metadata. And so it's been a long discussion and will continue, I'm sure. So
it's a sensitive issue, but it's to me, sounds like a wonderful solution, because these merged, everyone is making their own merges. So why don't we provide a merge that is done with the best practices? So, all right, Andy, I think we have you next.
Sounds good, thank you. Let me get set up here. How's that? Is that coming through? Perfect, thank you. I'm a Teams guy, less Zoom, so this is kind of a less familiar platform. So yeah, it's a relatively small group here, which is great. I'm going to talk a little bit about the ARM program and where Sandia fits into this. So we help support the North Slope of Alaska observations. So it sounds like you're all relatively familiar with ARM, so I can probably skip over a couple of slides here, but yeah, just a quick outline of what we're going to talk about. So a little bit about what is ARM, and then going specifically about Utqiaġvik and some of the other partnerships we have, things that we've currently got on site, and things that we're trying to do to plan forward, moving forward with new improvements to the NSA site. I can talk a little bit to some of our other work that we've got up in the North Slope as well. I was mainly trying to just focus on the ARM side of things here. I act as the Sandia contact to the ARM IMB for the North Slope of Alaska site, as well as the tethered balloon system, which is another capability that ARM offers. And for those that aren't familiar, I'm sure you're all aware of this, right? There's 3 main sites for long-term measurements through ARM. So there's the North Slope of Alaska, the Southern Great Plains site, and the East North Atlantic. The North Slope site has been around for 25 years this year. So we're going to be celebrating that as part of the NOAA, which is the Naval Arctic Research Lab 75th anniversary, which is happening up in Barrow in August. So we'll have a booth and some presentations there. So if anybody's traveling north during that time, please stop by. So for those that don't know, this is basically what the site looks like currently. So we've got a number of containers that are elevated up on platforms. Most of these containers have been around since 1997. We've done some upgrades, and I'll talk a little bit to what some of our upcoming upgrades are going to be. Obviously, up in the Arctic, there's a lot of maintenance. There's a lot of things that can go wrong, so we want to be keeping track of that and make sure that we've got site operators available. And we partner with UIC, which is a corporation up there that helps support our technologies in the field. So they'll be out at the site doing rounds, making sure the instruments are all operational, things like that. And then the Sandia team helps support things of more of a technical nature, travel up there fairly regularly, do improvements, support fields and guest instruments that come on site, and as well as just continue the operation of other instruments and provide support to the UIC folks. Just to put some context in here, so the Utqiaġvik site is in this kind of cluster of buildings right here, so we're pretty close to the coast and slightly north of the Barrow Environmental Observatory. And this will become important in a couple of slides, and we'll talk about this. So what is this site? What does it do? We have about 50 instruments that are supported through ARM. They vary from kind of in situ measurements through to radars and LiDAR systems, which have varying states of operation. We have automatic balloon launchers that help supported by National Weather Service as well. We've got a flux tower there that's taking observations. And the main kind of beauty of this site is we can bring in guest instruments. So anyone can petition to ARM to go into use the site and submit a field request, take up their instruments and deploy them there, and our team will help support that and keep things operational for them. As Sarah mentioned, there's a lot of data that's generated from here, and it sounds like you're integrating some of this in, which is great. I'm not too plugged in with the data quality side from ARM, but I know there's a big team that helps work on that and help get that out to the broader community. And all of this data is available online. There are larger field observation periods that happen up there as well. So I was fortunate back when I was in grad school to be part of the USDAC campaign, which was indirect, semi-direct aerosol closure experiment, and those aircraft flying from Fairbanks, which I was on board with, but there's folks on the ground in Barrow doing measurements as well. So, you know, these larger campaigns, which are great to kind of collaborate on. We have a number of ongoing field campaigns right now, and thanks to our colleagues at NOAA as well, who are hosting some of these instruments in some of their lab space. So the PINE instrument, which is from Naruki in West Texas, is currently situated in the NOAA observatory across the street. We've got work with distributed acoustic sensing, GPS work, other radio sonde efforts that are matching to satellite overpasses. And one of our continuing projects is the SALVO, which is a seasonal evolution of land and sea ice albedo. This project's been ongoing for a number of years. It took a little bit of a pause during COVID, but now SALVO 2 has returned, and we've just had some folks up in the field about 3 weeks ago, that were up supporting these observations of snow and ice melt, and some of that being at the NSA observatory and some of that at the BEO site, which I'll talk to. Yeah, the photos here just giving you a bit of a flare of the different range of things, right? From lab-based instruments here on the right to platforms that will be out and fully exposed during the winter months. We've got support for experiments that go out onto the sea ice as well. So it's a number of different efforts there. One thing that's lesser known is that there's the Barrow Arctic Research Center, or BARC, which is the UIC building. This was built in mid-2000s, 2007, and it's on the NAL campus. We actually lease a lab space there as well. So for folks that go out to the field, collect samples, we've got somewhere that's kind of warm and enclosed. That's a proper lab space to be able to help support their measurements. So if they're doing any kind of field samples and collections that they need to be more delicate operations with, and we can use that space. And this all is encompassed with the ARM program as well. So the space is available for those that need it. Additionally, the duplex. So this is available for visitors that come in through ARM to have a place to stay, particularly when we're in the summer months and the tourist seasons that occur, where there's only a limited hotel space up in Barrow. So we have this available for folks. It also helps support our teams when we go out to the field as well. So we've got a base of operations, and the UIC observers work from there as well. So we've got a data center and everything there to help manage data and check on the site remotely when we don't need to go out to the actual field site itself. So thinking about moving to the future and measurements of the NSA, one of the big changes we're doing is we're installing a new Vasel or autosonde launcher so we can get regular radiosonde launches. This launcher uses hydrogen as a lift gas. So we have a hydrogen generator on site. It's really difficult to get helium and expensive to get helium up to the North Slope, particularly now when it's very difficult to get helium at all. You know, we're very thankful that we have this hydrogen generator. Other ARM facilities are looking to move towards this in the future, just because it is a more robust system that we're not relying on deliveries of helium, which are in huge shortages right now. We currently have an auto launcher there. It's had some problems in the past, so we're moving towards this new system. We will maintain the old launcher and turn that into a helium manual launch system. So if there is ever any failures with the hydrogen generation, or we need to do off normal launches, we can do that with the helium lift. We're also moving towards or thinking about a new instrument shelter for aerosol instruments and cloud microphysics instruments. And this would be on one of the existing platforms, just basically extending out where the guest shelters are. And this would give us more space to be able to collect more measurements. We've got interest from folks in kind of mass spectrometry up there as well. So we need a bit bigger space that can handle the weight of some of these larger instruments. So just trying to think ahead to the future. And really, I encourage anybody, so anyone on this call and others that have interest in North Slope measurements, if there's things that they see that they would be good to have, you know, measurements for the future, to let us know. You know, the ARM put out a number of kind of working group meetings where we can talk to how to improve things like radar systems or LiDAR systems, and we're always open to ideas. So if anyone does have a wish list of instruments or techniques that we'd like to see up in the Arctic, please let us know, and we can kind of see if we can fit them in. So not just on the science side, we've got a number of improvements as well that are just general maintenance improvements. Where this site's located, it takes a beating, right? You're in the North Slope of Alaska, so you're going from 30 degrees in the summer to minus 60, minus 70 in the winter. Got a lot of salt there, and then just the sea is, I think it's about a kilometer away from where we are on site here, and it can take a lot of toll on the instrumentation. It takes a lot of toll on just the infrastructure itself. So you can see some of these pictures here of some of the decking and things that we've got. So we're getting this all fixed up, replaced, bead blasted, and coated so that it can be protecting for the next 5 years. A lot of that's going on this summer, and it was something that we've delayed basically because of COVID. So we're trying to get those improvements made. And then because of the nature of the land surface, there's a lot of shift in the ground surface. So we're improving the decking and other railings that are there for safety as well. So a lot of activity going on this summer. One of the big changes we've got is this new BEO site. So this is the Barrow Environmental Observatory. And if you look at this figure on the top here on the right side, this is where the current NSA site is right now. And we've leased this small parcel of land down here to the south, which is going to be more of an inland exposure environment. And so we've got some snow measurements occurring down there right now. It's pretty rudimentary what's available, but we're working to get power and data and comms to this site as well so that we can telemeter back data to the NSA site. And so this will be a new environment here that we can take measurements that are more inland, less coastal. Some of the PIs that we're working with are seeing examples of more inland changes to things like snow accumulation and snow melt. So this is something that we've really put in this last year, and we're moving towards increasing the usage of. Other partnerships, so obviously we're working with National Weather Service, particularly with the radio sun launches that we do and the hydrogen generation, ongoing campaigns with NOAA as well, and the kind of local organizations and corporations there like UIC and the local schools. A lot of work with UAF. They help support a lot of the work up here as well, so we're appreciative of their support and direct ties. At Sandia, we've got a number of lab-directed research and development studies as well that are focusing on both NSA and Utqiaġvik Point, which is just to the east. We being Sandia, manage a site there that's got restricted airspace, so we can do things with UASs or tethered balloons there a lot easier than we can do in Barrow itself. So a number of different endeavors and projects that we've got going on in those locations. Then I mentioned earlier as well, tethered balloon system. I'm assuming you have some familiarity with this. People have seen this before, but this is another arm capability that we manage out of Sandia. We've got a great team here that can fly these balloons, currently deploying down to Houston to the Tracer project, as well as Crested Butte for sale. And this is a tethered balloon that typically we can fly up to about 1.5 kilometers from the ground level and instrument with up to 70 kilograms of payload. So, we can get these nice profile measurements or loitering measurements in the atmosphere, depending on what the PIs are interested in. But this is something that's been up to the Arctic. We've flown this at Utqiaġvik. We've got some thoughts on trying to fly this at Barrow as well. And we've done some great kind of ice cloud measurements at Utqiaġvik in the past. So something that's available, and it's a great capability that ARM has. And really just closing out here with some example of some of the other partnerships that we've done and the other types of work. So we've got a laundry list of folks that we work with and partner with. A lot of this is through ARM, but I mean, as you're all aware, with working up in the Arctic, it's all about the relationships you keep with the folks that are around. And so we're happy to work with everybody that's up there, and anybody that's really interested in being up in the Arctic and taking data and collecting measurements. So yeah, with that I can kind of close out, and if there's any questions or anything, yeah, appreciate it. Appreciate the time today.
Thank you, Andy. That was impressive. It's exciting to see all that work that you all are doing and helping to support. Questions for Andy, or maybe we can save questions for the end? Ryan, did you want to get started and then we'll have questions at the end?
Sure, that's fine.
Okay, I
think that I can share my screen. My computer was totally frozen before, so I'm going to try sharing the PDF version, which I hope is okay and lower bandwidth. Can everyone see that all right?
Yeah, that looks good.
Okay.
Well, thank you, Meredith. Appreciate you sharing the slides. So I appreciate the opportunity to talk about what we're doing up in Utqiaġvik. I manage 4 atmospheric baseline observatories for NOAA. These are the 4 sites. We span the Pacific north to south, from the North Slope through to Mauna Loa and American Samoa in the middle of the Pacific and down to the Antarctic to South Pole. These kind of form the backbone of NOAA's sampling networks. We like to think of it as sort of a gate, and all these air masses are moving past them every day, and we're going to catch them in both hemispheres as they move around the planet. Next slide. So Barrow, Utqiaġvik, as you all are familiar, is along the North Slope. Our facility, as Andrew pointed out, we're about 8 kilometers to the north and east from city of Utqiaġvik, up along the coast. And it's really an amazing partnership that NOAA, USGS, and DOE have formed over the last multiple decades. We've been on site since the early 70s, along with USGS. Each agency has about a 100-acre parcel of land. And as Andrew said, DOE's been there right on our property line between where the NOAA parcel and the USGS parcel come together for the last 25 years. And it's really amazing to see all of this science coming in from the North Slope. And what you're putting together, pulling all this into one place, I think is really going to further our efforts. It's really pretty great. So yeah, the map on the bottom left is a little small, but there is a red dot. It's very similar to the one Andrew showed of kind of where we are in relation to the city down to the left. And I'm using the term city loosely. And then you can see the different facilities that are there. This is looking back to the west with a drone from just outside of our property, and an older photo before we did our renovation work that I'll talk about next. Next slide. So we've been up at Barrow. Like I said, our first measurements were taken in early 1971, just testing the location. I believe April of 71 actually predates NOAA as an agency. I think we came online officially in 1972, or maybe it's 70. It's one or the other. And our facility was actually built and dedicated in 73. It was a temporary building put together by the Navy for us. You can see a photo of that from 75 down in the bottom left, that black and white aerial shot. And you can see from 75 to 2015 in the top right, not much changed. We added a garage in the early 2000s, 2001 or so. We put a garage facility in and did some road improvements, but that's about it, over those 40 years. And I think what you'll see with our new observatories, we've really tried to up the ability for us to support science at a world-class facility along the North Slope. So yeah, I mentioned the acreage. We do have well over 1,200 publications using the Barrow data sets. This number was from 2018. Last time NOAA had us do a laboratory review. So we did the data sleuthing to see how many publications use Barrow data. So this is quite old. So I'm fairly confident this is probably north of 1,400 publications by now. Next slide, please. So when we were given money by Congress to build this new building up along the North Slope, we've been asking for quite literally close to 30 years to get the facility funding, and asking seriously for probably 20 years. So when we finally got the money, we had a pretty long list of design requirements of what we wanted to do in this building. We wanted to up our science space. We wanted a kitchen and bathroom facility. The old building had no running water. So we wanted to fix that for our staff and for our visitors and visiting scientists. We wanted to bring the building up to IT standards, have a dedicated IT room, server room with cooling to bring fiber connectivity to the building, and support our science mission a little bit better. So next slide, I'll talk about most of these next slides. So here's some some imagery. We were given funding in 2018. You can see the photos on the left, those 4 images. The construction was year-round. To put pilings in the tundra, you need to do that when the ground is frozen, so you don't destroy the active layer, the top couple feet of the soil. So that was done when the ground was frozen. They dropped the pilings in, let them go through a freeze-thaw cycle, and the following, which is the bottom left picture in green, that was the summer. In the fall, the building foundation started coming up and it went through the winter. September of 2020 was when the actual substantial completion was completed for the observatory. That's a pretty big milestone in construction world, mostly for the vendor because that gets it off their insurance books and over to the government as our asset. But it really meant we could essentially move in, and our science became operational in the building in October of 2020. We did take web images every 5 minutes from our camera and archive those. We put together some pretty neat time-lapse movies to watch the construction happening, watch the conditions change, you know, from the summer to the winter to storms blowing in and out. It was really pretty entertaining and time-lapse. So there's, and they are all on our website if you're interested. Next slide. Couple photos, just looking around the facility. I will talk about these in I think with the next slide. But the top left, we've got a large 1,400 square foot roof deck with power. We also have some roof hatches. One is being used by NOAA for our Dobson measurements, looking at the zenith. But we also have another roof hatch in the cooperative science room that we kind of penciled in on paper back during design. That could be a micropulse LiDAR or something similar. We've brought fiber to the building, which also meant we were able to connect the lab with cable trays throughout the lab spaces to make it very flexible, easy to plug in power, easy to route cabling, easy to route inlets from instrumentation outside on the roof or out on our sampling tower. And all of our lab benches are mobile on wheels, which makes it very modular, so we can configure as our design requirements and science requirements change. We have an outreach area and kitchen space, so we can bring in local school groups and give tours, get them out of the cold into a warm space to give talks. We do have a campaign science deck. The bottom left photo, it's a little harder to see, but you can see the driveway coming into the photo from the right. And just on the north side of that driveway, actually, sorry, west side of that driveway heading towards our DOE colleagues, you can see a gray platform, and that's a 20 by 30 platform designed to hold 2 20-foot sea containers. We have a power drop to be able to power 2 different containers at the same time with a space at the end to be able to open up the doors so you could do work and get in and out of the containers. We wanted to facilitate mobile campaigns that were coming through the North Slope, buoy calibrations, different science that maybe, you know, up on the roof of our building wasn't the best place. But instead of having to put more pilings in the future as one-offs and working with our BLM colleagues and working through the NEPA process to get permission, we wanted to have a platform ready to go for future science. And we also installed a new 30-meter sampling tower with power and meteorology. Next slide. So the idea was we really wanted to, you know, first and foremost, to further NOAA's science mission, be able to support our mission, which we were quite honestly struggling to do with power and temperature issues in the old facility. But we also want to now support more Arctic science. We've increased our square footage of space, and I'll talk about how much we've done that on the next slide. But we really do want to see, you know, other collaborative research come in, and this slide is, you know, my question is, why would you host at Barrow? Why would you want to be in the North Slope and be at, you know, at the NOAA site, at the DOE site? Hopefully you're seeing, we're painting a picture that there's a lot of science already happening there. And it's a very easy addition to bring additional science in facilities that are pretty much ready and waiting to host more science. And with a vast array of data sets already going, and some of which are 40 to 50 years long, really providing a nice long-term background. We have a lot of collaborative partners between our DOE colleagues, USGS, our NESDIS colleagues that are doing satellite work, the BEO work that's happening out just to the south of us. Something we're really excited about doing right now is we have a procurement action going through to buy some temperature thermistor strings that we're going to put into tubes that are around the observatory. Every one of our pilings that we put in for the new building, the new tower, and that campaign science deck, every one of those pilings has a thermistor PVC tube attached to it that's empty at the moment. I think that gives us 67 or 68 total boreholes across our site spread out. We're trying to buy a thermistor string and data logger that allow us to instrument probably about 8 of those at the moment. And those pilings are 17 feet deep. So active layers, the first 2 meters or so. So really probably 1 foot intervals with thermistors going down that full 17 feet at multiple locations, which will be an engineering thing for us to watch that the tundra underneath our building, isn't thawing out and we're not seeing any differential settling, but also to be able to hopefully better connect our atmospheric science with our terrestrial science partners that are trying to look at what's happening with permafrost warming and the release of methane, et cetera, from the warming tundra. A couple simple plots of the available data sets we have as NOAA products. Next slide. So this is sort of bringing it all together. This is the new capability we have with the new site. We've added, we now have 3,400 square feet of science space between the indoor warm space, that roof deck, and the science platform. We also have that 30-meter tower. Just for reference, the previous building, the original observatory, was 980 square feet. That included an office space, a couple of servers for NESDIS. So science space in that building was probably somewhere in the neighborhood about 600 square feet. And we had a relatively small, let's say 400 square foot roof deck. So we've probably gone from about 1,000 square feet of total availability for science sport to 3,400 square feet with the new facility. We have that roof deck with power. We have the secondary lab space, which is what I mentioned earlier that we penciled in for a micropulse LiDAR, but we have a roof hatch and a lab bench directly underneath it in that secondary space. We've got the kitchen and restroom. We've got an outreach opportunities with our new facility space and connectivity. We can bring our science, not just ours, but our partner science, including DOE and USGS. If we can connect our science from the North Slope down to facilities and classrooms with our new fiber connection, that's sort of the goal and why we invested in the fiber connection to the site. We also installed a battery backup for the entire building. So we have a lithium battery that can run the facility for multiple hours, all the science. I mentioned this permafrost temperature strings we're looking to install. And we're really looking to now to encourage other partners to test instrumentation, do Arctic science up along the North Slope with us. So next slide. So I'll just wrap it up with this. We're looking to facilitate more science for NOAA researchers, but also with our partner agencies, universities, international partners. Something I didn't mention is that we did require UIC, who was our building contractor, UIC Naperia, it's their construction contractor. They did build this building for us, design build, and we required them to be LEED certified on this facility. And for those that aren't familiar, LEED certification is by the US Green Building Council, and basically make sure you're building a sustainable green building. We wanted it for a couple of reasons. One, to show our commitment to the Arctic as an agency. Two, to show that if you build smart and sustainably and a well-insulated building, we're going to have better temperature control. We're going to use less energy to do that. And it's better for our science in the long run. So we pushed them to become LEED certified. LEED Silver is the next level up from being LEED certified. We actually were 3 points away from being LEED Gold. And no matter what we did, we couldn't figure out how to get those last couple of points to make this a LEED Gold facility. But LEED Silver is still an accomplishment in a place along the North Slope that has no roads. It's pretty great. We did put fiber to the building, as I mentioned. And now we're just looking to, as I've said a couple of times, we want more collaborative cross-disciplinary research to come fill up our building. We want to be back in the problem where we have a full building of science. And that's not the case now, but we hope it will be soon. So I think next slide. That should be it. So I appreciate the time and the opportunity to talk about what we've been doing up in Utqiaġvik in our new building. We have a really great story map that our NOAA communications folks put together, talking about the building and the science that's up there. So it's kind of a hard link to follow if you're not able to click on it, but it'll be in the slides that are shared. So with that, I'll stop. Thank you.
Thanks, Brian. That is an amazing facility. It's I'm sure there was a lot of difficulty in getting it finished, and with COVID and all the other things going on, but it's great to see all these advancements between the different agencies, and Sarah's efforts to get a unified data set. Is there any questions or comments from the rest of the team?
I had one comment, Brian. What's well, first off, I'm super excited to hear about the thermistor strings because my background is ground heat flux, so I'm very excited to hear that. But what's going to happen to the other building? Sorry if you already mentioned that, like the old facility.
The old facility is no more. If you look at our webcam right now, you'll see that it is no longer there. So we had to work with our State of Alaska State Historic Preservation Office folks to work through the process of being able to get rid of it. It was actually deemed a historic district, not just the building, but also the old Dobson Dome, et cetera. So we had to do a bunch of work to meet the state requirements. But ultimately, due to snow drifting and that building, those pilings were rotting out. So that building was going to fall over. You don't think of a place like the North Slope as having rotting effects on wood, but for 2 months a year, 50 years later, it starts to happen, right? So those pilings were starting to really, you could push a screwdriver right into them and chunk out chunks of wood. So the SHPO did allow us to take those buildings down. We had to document them, create a website, et cetera, but all the old stuff is no longer there. So we have a little bit of, now that the snow melt is just happening now, you'll be able to catch us right now because you can see there's a lot of stuff on the tundra after the building was demoed last October, November. And now that the ground is clear, the snow is melted, our contractor UIC is going to come in and do their final tundra cleanup, put out some native grass seed to remediate that ground. But it's a nice clean site for snow drifting and for future research.
Other questions?
I have a gory detail. First, just Brian, that whole thing is wonderful. That's just fabulous. I have a really detailed question for Andy, if nobody else has a question. All right, I got the thumbs up. Andy, I've been working with the radiosonde data from Utqiaġvik and taking more of a climatological perspective. And I've noticed, and Emily is going to be working with those data too. I've noticed that the first point on many of them has an altitude of 27 meters. That's typically the surface observation. And the ARM website says that Utqiaġvik, that your site in Utqiaġvik is 8 meters above sea level.
Yep.
So I'm wondering, there may be a scale thing here. I wonder if you can explain to us how the first point in the balloon would be 27 meters above sea level at an 8 meter above sea level site. I'm sure it's like decking that I'm unaware of, looking at these buildings, but it would be nice to be able to explain it to people.
Yeah, that's a great question. I'm just trying to think. So the way it's currently set up, and this is from the AutoSonde launcher, is that correct? Or is it manual release?
Most of them are, yeah.
Okay. So we're on, let me see if I can find a picture of this. If I can share my screen again. Window. Let me know if this is coming through.
Yep.
Yeah, okay. So this is where the AutoSonde launcher is, which is on top of this platform, right? So this is obviously, even if this was at 8 meters sea level, we've got a few meters on top of us. I don't think it's at 27 meters though. And so I'm wondering whether there is a first data point that's maybe missed as it's launching, and there's some number of seconds between the actual launch to the first data point that comes off into the data set. Because basically that clamshell opens up and the balloon goes.
So the balloons tend to rise at about 5 meters per second.
Yeah.
So
yeah, that would be hard. Okay, how can you estimate for me how high the large structure with the decking on which the two buildings rest, how high is that above the ground? Surface the buildings are on? That platform. Roughly.
It's probably going to be about 15 feet, I would say.
So 3 meters.
About 3 meters. Oh, 5 meters.
That's
That's
5
fine.
meters. I'm sorry.
Yeah.
So 5 plus 8.
Yeah.
And there is terrain variability.
Yeah. I can get a measurement of what height this is at for you. We just had a team. I was there a couple of weeks back. We just had a team leave, so I can probably get that measurement for where that is above ground absolute level.
Okay, this has just been a curiosity, and
Yeah.
you know, we get questions occasionally when we're giving a presentation. I will shoot you an email. So
Please do. No, this is I've never seen that, but there's a lot of data that comes out of that. So
I have to apologize, everyone. I have to run to my next meeting, but
thank you.
Thanks, Barry.
wonderful time.
But yeah,
Oh.
Leslie, I can certainly look into getting a value for you there. We might already have it somewhere, saved in a file, but I can look to that for you.
Okay, thank you very much, Andy, and thank you everybody for your indulgence.
No problem.
Such a small group, I thought I'd give it a shot.
Yeah, no, it's certainly time to find out. So.
Well, with that, I'm happy to stay on if there are more questions, but if not, we can close the meeting. Either way, good for me.
I have to run to another one, so thanks everyone.
Yeah,
I do
thank
as
you very
well.
much. Yep.
Thank you.
Bye.
Bye.